Welcome. In this video, I will be integrating 1 over the square root of x squared minus 49 dx. This integral is of the form x squared minus a squared inside a radical. When you have an integral of this form, you want to use the substitution x equals a secant of theta. In this case, a equals 7, since 7 squared gives us a 49, which is what we need. So x equals 7 secant theta. This means dx is equal to 7 secant theta tangent theta d theta. Furthermore, x squared is equal to 49 secant squared theta. Now let's go ahead and make some substitutions. This becomes, and I'll write the denominator first. I'm replacing x squared here with 49 secant squared theta. So that denominator is 49 secant squared theta minus 49. And then in my numerator, I should have 7 secant theta tangent theta d theta, since I had to replace this dx with this entire quantity. Okay, so this is 7 times the integral of secant theta tangent theta divided by the square root of 49 times secant squared theta minus 1. d theta, so I can simplify this further, is 7 over 7. The square root of 49 in the denominator comes out here as a 7. Secant theta tangent theta divided by the square root of secant squared theta minus 1 d theta. Recall that tangent squared theta plus 1 is equal to secant squared theta. This tells me if I just subtract 1 from both sides, I can see that secant squared theta is equal to, secant squared theta minus 1 is equal to tangent squared theta, which I have here, so I can make this substitution. So I have the integral of secant theta tangent theta over the square root of tangent squared theta d theta is equal to the integral of secant theta tangent theta over tangent theta d theta. Those just become 1, and I have the integral of secant theta d theta. Again, this is a video I've done already, so if you're following along, you've seen this integral. If you haven't been following along with either my Canvas course or YouTube channel, go up here. There should be a link popping up in your screen somewhere about now. I'm kind of bad with placing my cards, so hopefully it's close enough that you should be seeing the link on how to integrate this. So this becomes the natural log of secant theta plus tangent theta plus c. It's time to turn to our old friend right triangle trigonometry to finish fixing this. That is, back substitute to our x's because we have thetas, and that's not what we want to end up with. We already know that x is equal to 7 secant theta. This means secant theta is equal to x over 7. What we don't know is what tangent is, and I have a tangent here, so let's figure that out. Secant theta is 1 over cosine, so cosine theta is 7 over x. Cosine being the adjacent side over the hypotenuse tells me that this side adjacent to theta is equal to 7, and the hypotenuse is x. Using the Pythagorean theorem, I'll label this side y, and I'm running out of space, so I'll write it here. We can see that y is equal to the square root of x squared minus 49. Okay, so now that we have that, tangent theta is opposite over adjacent, so that's this side over this side. So tangent of theta is equal to this radical divided by 7. Okay, so let's write this as the natural log of x over 7 plus the square root of x squared minus 49 divided by 7 plus a constant. Rewriting this a little more, I end up with the natural log of x plus the square root of x squared minus 49 over 7, and I'll call this c1 plus c1. Now I can avail myself of the fact that the natural log of a over b is equal to the natural log of a minus the natural log of b. In this case, a is here in the numerator, and b is the 7 in the denominator. So this is just the natural log of x plus the square root of x squared minus 49 minus the natural log of 7 plus c1. Letting c equal c1 minus the natural log of 7 means I can replace this with just c to end up with my final answer of the natural log of x plus the square root of x squared minus 49 plus c. I hope you found the explanation of the calculus techniques and some of the relating algebra and trigonometry concepts helpful.